Today we are solving a question from the spring 2018 paper 12 using conservation of energy in a circular path. Let's read the question. A bead is released from rest at point P and slides down a wire as shown. The track loops around and forms a vertical circle of diameter 40 centimeters. At point Q, the bead has a speed of 1.4 meters per second. Air resistance and friction on the wire are negligible. What is the height from which the bead is released? First, let's identify the types of energy at the top of the track and at the top of this loop. At the top of the track, the object has potential energy because it's at height above the ground. There is no kinetic energy at this point because the ball is released from rest, meaning its initial velocity is zero. At the top of the loop, the object has both potential and kinetic energy. This is because it still has a height above the ground and is moving, so it has speed. Next, we are going to apply the principle of conservation of energy. This principle states that the total energy at the top of the track is equal to the total energy at the top of the loop. From the question, air resistance and friction are negligible, so we can proceed by considering only potential and kinetic energy. So we add the potential and kinetic energy at both the top of the track and the top of the loop. Next, we need to know the formulas for potential and kinetic energy. Potential energy is the product of mass times acceleration of gravity and height. In abbreviation is mgh. Kinetic energy is the product of half of mass and velocity square. Now we substitute the formulas in the conservation of energy equation, and we notice that mass appears in both terms of this equation, so we can go ahead and cancel m. Now let's rearrange this equation to solve for the height h. Remember to convert 40 centimeters to meter, since the acceleration of gravity g is in meters per second square. So 40 centimeters is equal to 0.4 meter. Now we are going to perform the calculation, so use your calculator, and we should have a height of 0.499 meter or approximately 50 centimeters. Let's check if 50 centimeters is one of the given option, and yes, the correct answer is C. Thank you so much for spending time with me today to solve this question, and I hope you learned something new today.